Chemistry time. I don't know why I wrote that. I was right, but I did this time. Anyway, today we're talking about dimensional analysis. Dimensional analysis. Let's just break up these little words. What up with analysis? You know what that means. What does that mean? In layman's terms. Yes, go ahead, Peyton.
To study.
Sure.
To study up.
Yeah, that's fine. Study. I was thinking look at, but yeah, like if you analyze 1976 penny, or the 1976, what was it, the biannual one from when America was 200 years old, and there was a $50 that had the Liberty Hall on the back, and that's not a rare, but a somewhat uncommon $50. Even $50 themselves are pretty rare. But anyway, if you look at that, you have analyzed it. That's what analysis is. Dimensional refers to what?
Dimension.
Yeah, but when we're talking about dimensions in science, okay, yeah, the shape of something, but specifically it's what's? The shape is true, but mostly, usually it's what? Say it.
Measures?
Yeah, the measurements. Measurements. This morning I went over to visit with Mrs. Lemon about what we ought to do for the one-act play, which we got somewhat solved. But on her desk I noticed was a little yellow, legal tab, and she had written the dimensions of all the cheerleading girls on there so that she could buy them clothing, right? That's their measurements. Their list of measurements tells her what shape and size they are so that when she buys the shirts, they're the correct shape and size, right? That's what dimensions are. And we even use that, if you're looking for pants, you're looking at the dimensions of the pants. At least for males' pants, is what I'm familiar with buying. It's something like 30 by 32. And it's in inches, and for women it's something crazy. It's like
0,
6A, 1, and then you're like, oh, I gotta find the bigger size, and your wife is like, oh, this one won't fit me because it has this letter, and I'm like, I'm gonna go to the car. Anyway, but the dimensions that are given for men's pants, at least, that actually very seldom happens to me, that story, but the dimensions for men's pants are the circumference of the pants by the length of the inseam, and so that's the measurements. So we're talking about the looking at, or study up if you're fancy, about measurements. So, and what this means is that, and we usually call this what? What's the code name we use? Actually, this is probably more accurate. We call it unit conversions. Your textbook, and it's officially called dimensional analysis, but I call it unit conversions quite frequently. Because we're doing what? In this one, we don't have to break this down too much, but we're converting units. We're changing from one unit to another unit. Let's do some simple ones. We have 4 methods we're going to use today. I'm going to write that over here so I don't forget them. 4 methods. The first is basic. What do we do first in a basic unit conversion? Well, let me give you an example of a basic unit conversion. We're going to say that Mitchell, do you receive on the football field? Are you a receiver? Mitchell has caught a receiving pass and he made 31. Yeah, Mitchell has fumbled a receiving pass that would have been 31 yards.
Actually, the one I caught was longer than that. It was 37. Thank you.
Let's change it. 218 yards.
Thank you.
They went to stops and they were like, Mitchell! Because he was an excellent receiver. Anyway, 218 yards, and Mitchell wonders in his head, how many feet was that? So this is a basic unit conversion. We're going to convert 218 yards to feet. Step 1, I'm trusting you because, as far as I know, all of you but one has been taught this before because I physically stood here and taught it to you. So
you write 218 yards.
We write our given, 218 yards. Step 2.
Over.
No. Not necessary for this.
Times.
Yeah, we use our conversion bar. And then do it in this order. Say to yourself, I'm going from yards to feet. Or if you want to use the passive voice, convert from yards to feet. Okay? Put the units in first though and start with the unit you're getting rid of. Do you know what I mean by getting rid of?
Yeah.
I mean,
cancel.
Yeah, I mean I'm going to reduce that to 1. That one, the one I'm reducing to 1, goes on the opposite side of the fraction bar to where it is. So right now it's in what? It's implied. Because this is actually over 1, as Kyla says. But this is in what part of the fraction?
Top. Numerator.
Numerator. And so in order to reduce it to 1, I need to put that unit in the denominator. And I need to get 2 feet, which I put in the numerator. And then, after I've put the units in, starting with the one I'm getting rid of, I say to myself, South, in 1 yard, there are 3 feet. And say it exactly like that. In 1 yard, and as you say that, write the 1, there are 3 feet. And this seems really pedantic at this point, which means that, like, I'm going through all these steps. But for this one, it is kind of, because this would be a pretty simple one even to do, like, in our head or just with a calculator. But if you do them, this is my whole day philosophy of my life. If you do them this technique while they're easy, like this one is, then when you get to one that's difficult, like we will in stoichiometry, not difficult necessarily, but more complicated, you don't have a problem because you've been doing it the right way the entire time. So I know this seems like overkill, and to some extent it is, but if you do them the right way at the beginning when it's easy, you can do them later on much more easily when they're hard. So all we have to do now is convert, and by doing that we multiply this by this. Everything on the top we multiply, and then, but first 218 times 3
is
654.
You just did it in your head. 654, yeah, because 200 times 3 is 618 times 3 is 54. Yards reduced to 1, we're left with feet. The answer is feet. 654 feet. Okay, that's a basic unit. The next one that we're going to talk about is called chaining, or I call it chaining. I have actually literally never heard any other document or person call it chaining. I made it up, but to me it seems like it fits. They chain together. So in this one we're going to convert from, I'm trying to think of another good story problem for you. Who wants to begin the example? Do you? All right. Let's say that Kyla, I'm trying to think of how we can do this the best way. Let's say that Kyla drinks 167 gallons of Mountain Dew Code Red every week. I should use this for the rate one actually. But we're going to convert from gallons to liters, okay? She's moving to France, and she wants to know how many liters of Mountain Dew Code Red she needs to buy, because they don't use gallons in France because they're a real country. Okay, what do we do first?
167 gallons.
167 gallons. We're converting from gallons to what? There is a conversion from gallons to liters, but we don't know it. So we're going to convert from gallons to quarts, which actually, coincidentally, I don't know that either. So, and then we're going to convert from quarts to liters. Actually, no, listen. I'm not an idiot. I do know how many quarts are in a gallon, Lily. There are 4 quarts in 1 gallon, but I don't know how many liters are in a quart. I think it's something like, it's either 0.946 quarts in a liter or the other way around.
How many, we want to know how many
Quarts
liters
in a liter, yeah.
How many quarts in a liter?
Yes.
1.0566.
Okay, do the other one. How many liters in a quart? That's the one I was thinking of. I knew I was wrong, because I was wrong.
0.946353.
So I had it right. I had 0. Someone confirmed that. You can watch it in the video. I had 0.946. I just had that was how many quarts in a liter instead of how many liters in a quart. Anyway, math it up. We know that gallons are going to reduce to 1, quarts are going to reduce to 1. We're going to be left with liters. This tells us how many bottles of Mountain Dew Code Red, Code Rouge, because it's French. I think code is the same. Has someone done the math where I don't have to keep talking about French? I think code is the same though. Code Rouge. It would be, yeah, it still would be, because I don't know why the Code Red in English is, why would you do the red instead of red code? I don't know. Are you about to tell me?
I'm 0.946. Nope. I put 1.946.
Good.
631.
631. We'll leave it at 631 because significant.
Significant digits.
That's right, significant digits. We have 3 significant figures in our given. We have 3 then in our answer. That was true also back here. Oh, as a side note, I'm all about these side notes. Exact values. This is the side note area. Side notes. Exact values. For example, 3 feet in 1 yard do not count when, I was going to put worrying about, when observing, there we go, sig figs. Is this an exact value? 0.946 liters in 1 quart? It isn't, because she just told us it's actually 0.94613, whatever, a whole vomit of numbers afterward. So that's not exactly, but this is. They're exactly 3 feet in 1 yard. This has infinite significant figures. So what was our lowest number of sig figs in this one back here? 3. We had 3 sig figs here, so our answer needs to have 3 sig figs. In this one, our lowest number of sig figs was 3, and it was 3 here too, because this is an exact value, so we only needed 3 sig figs. Would it have been good for us to use 0.95 for this? No, because then that would have had 2 sig figs, it would have reduced the number of our givens, sig figs. What about this?
Exact.
It's infinite. It's infinite because it's exact. Because there are exactly 4 quarts in 1 gallon. That's why it's called a quart. Does this number make sense? Sure. Sure it does. This is roughly 1. 4 times, this is basically 150 with a little. So this is 600 with a little. So there we go. That makes sense. Let's do number 3. Number 3, we're going to call this one rates. This one would have actually been a better one to use that example of. I do get more in depth in this in the physical science lesson, which is posted on the youtube.com. Have you heard of YouTube?
No.
If you go to youtube.com and type in, go to www.yahoo.com, and then when that comes up, type in the search box youtube.com, and then when that comes up, click on the top one, and then when that comes up, type in Mr. Kime Science or something like that, and then you'll be able to watch it. Anyway, I was going to say, I do go into more depth in all 3 of these and that one because I'm trying to teach it a freshman, and it is mind-boggling how little they know. We're going to cut that out. We'll cut that. So rates ones are when we're talking about things, what's a rate? What kind of quantity is a rate?
How fast?
Yeah, there's something per something else. It's not always how fast, but we think about it usually in terms of speed. But any unit divided by another, the example I usually give as like a counter example when people say it's speed, miles per hour is a rate. But the one I give to show another example is that it doesn't anymore, or maybe it wasn't ever up here, maybe it's the ones downstairs, but the urinal in the boys' bathroom, I think downstairs, says on top of it in blue letters, 0.5 GPF, and that GPF stands for probably what? Can you guess? Gallons per flush. It's a rate. Every flush that goes by, 0.5 gallons are used. But there are all kinds of rates in the universe. When you work at Arby's, who works at Arby's? Do you really?
No.
Who hasn't ever had a job? And you get paid, what? Nowadays it's like $19.50 an hour, but that's dollars per hour, right? Every hour that goes by, you make that much money. So let's do one like that. Trying to do another one. Let's say that. What's your dog's name, Mitch? Spike.
No,
Spike?
not him.
Yep.
Vaughn.
Spike can eat.
is no.
Spike can eat 188
old.
peaches, cans of peaches, can and all, per week. And that's all they feed him, as far as I know. And we need to convert that to, we need to find out how many cans he eats in each. Oh, let's make it more interesting. Let's call it flats per year. They're going to buy these in bulk because they know he likes canned peaches. So they're going to think about how many flats per year. And let's just so you know, because I'm an adult, I know that cans come in flats, and there are 12 cans in each flat. The rest of it we should be able to figure out. So what do I do first? Well,
Write down your name.
188 cans in 1 week. I'm going to write it as that kind of fraction because this is still true, but this will help us with the math. What do I want to get rid of first? It doesn't matter. I usually do the numerator first. If you want to do the denominator first, that's fine. But I usually use the numerator first. So I'm going to get rid of cans and go to flats. And then, as Lily has mentioned, we can go to a week. But there's a little trick here. What do we have to do? What is it?
Household.
We have to do what, though? Since week is already in the denominator. Remember, the rule
Put
wasn't...
it in the numerator.
Numerator. Yeah, we want to put it in the numerator to get rid of it. The rule wasn't put what you want to get rid of in the bottom. The rule was put it on the opposite side from where it started. So since week is already in the denominator, we put it in the numerator to get rid of it. And we're going to years. Do, please, discipline yourself to put in the units before you put in the conversion factors. I really, really encourage you to do that. Put the units in first in order, and then put in the numbers. In one flat, there are 12 cans. In 1 year, there are 52 weeks. 188 times 52
Is
divided by 12 is
814
814 what?
point 6666667.
Okay, so 815 because we're rounding it. What is, hey, what's the number of, is this number exact? 12 cans in one flat?
Yes.
It is. It has to be because cans are quantized. Meaning you can't have 12.3 cans on a flat because it'd spill. It'd be a mess. The dog would like it, but no one else would. The Walmart employees certainly would not. Is there exactly 52 weeks in 1 year?
Yes.
Be careful.
No.
There aren't exact. I don't think so.
Depends what
There's a
month it
leap
is.
year too. So we can't. What's actually our lowest number of sig figs here? 2. So we have to have it be. Now I erased the whole dang thing. What was the answer again?
815.
So it needs to be 820 flats per year. So go on to www.peachesforsale.com and get your 820 flats per year for your dog. That's too many peaches.
I know.
Not your dog. That's too many for a dog. That's too many for anyone. Don't eat this many peaches. Dog food would have been smarter. I should have freaking put that in dog food. There we go. Okay, and then the last kind of dimensional analysis that we do before I set you free on some of them, and we will, after the video, we'll do some that are, we'll do some together, but these are just the instructional ones for the video. The fourth one, this one maybe we didn't do, I don't do this with the freshmen, Peyton, you may have already done this one, and I think maybe you guys did, I might have done this for you when you were freshmen, but I definitely did last year, and I definitely did this year. The last one, 4, are, what am I going to call this one? Let's just call it exponential. This is for things where we're using a square or cubic volume, or not volume, square or cubic distance measurement to measure either area or, did you do this last year? I really dropped the ball on these kids, yeah. I really dropped the ball on this year's freshmen then. So this would be for areas or volumes, things that are squared or cubed. So let's say, okay, here's an example. When you buy potting soil, it's measured in cubic feet. So let's say I buy a potting soil that is 1.03 cubic feet, and because I'm civilized, want to know how many, let's just go all the way, let's just go for liters. Liters. And I'm going to give you a unit conversion that you'll have to know forever in this. So 1.03 cubic feet to liters. So we start with cubic feet. This one's going to be lengthy. The conversion you're going to have to know in order to do this is that 1 milliliter is equal to 1 cubic centimeter. We had already talked about this, but do you remember this?
Yeah.
How does that help us here?
Because it's a liquid. No, it's
Well, it's a volume.
I don't know.
Yeah, it doesn't have to be. Remember, it's soil. It's not. But it is a volume. So what am I going to have to do with this? I'm going to have to from cubic feet to cubic centimeters, and then from that to milliliters, and that to liters. So how many from cubic feet to cubic centimeters? How many centimeters are in a foot? You don't know.
32.
It's not exact, but and here's the thing we use is that 2.54 is not exact, but it's 2.54000 and then something centimeters are in one. So I always like to go down to centimeters to inches because that one is almost exact. Okay, so we're gonna go from feet to what probably inches. But here's the rub. We have to do it 3 times in order to reduce out all these feet. So in the same way that x cubed is x times x times x, we have feet cubed is equal to feet times feet times feet. So if we want to get it to cubic inches, we can't just go times 12. Mr. Silly, maybe it was Mr. Jones, one of them when they're talking about concrete is telling me that the kids have a hard time because they think that there should just be 3 cubic feet of concrete and 1 cubic yard of concrete. Well, it's actually 27 because it's 3 cubed. Do you see the difference? Like, because they know about math, and students don't, especially the students who are pouring concrete. No, they still do. Be nice.
Wasn't that like holding people up?
I can't do it. Pour concrete. Actually, you know what? I have done it, and I didn't like it. So then we're going to go from inches to centimeters, but we're going to have to do that 3 times as well. And then we can go from cubic centimeters to milliliters, and then what? Milliliters to liters. And we do all the unit ones first. Do all the units first before you put your numbers in because it's right. Is it necessary? No, but it really will help you, I promise. Put your units in before you put numbers in. You don't have to do the arrow leading to the next one. That's just because I ran out of room. If you can fit all this on one line, God bless you. If you can't, please just do the arrow and go to the next one. But these things are just like, these are formatting things, not science things. Then you say to yourself, in every 1 foot there are 12 inches, and you say that to yourself 3 times. And then you say to yourself, in every 1 inch there are 2.54 centimeters, almost exactly. It has enough sig figs that we can treat this as an exact value unless we have like 9 sig figs, then we might have to go deeper. And then in oops, sorry, not this one. How many cubic centimeters are in a milliliter? 1, yeah, what a relief. And then in 1 liter there are 1,000 milliliters. So this answer is going to be, well, feet, drop out 1, 2, 3 with that. Inches, 1, 2, 3, 1, 2, 3. Centimeters, that with 1, 2, 3 of those. Milliliters drop out, and we're left with liters of potting soil. In my calculator, I type in 1.03 times 12 times 12 times 12 times 2.54 times 2.54 times 2.54. Forget that boy. Divide by 1,000 equals. Did someone do it yet? How are you guys even doing? Come on, this is a school.
We're writing this down.
What?
What does the last one say?
Liters of potting soil?
Yeah.
Milliliters to liters. Milliliters to liters. Remember the prefix milli means 1/1000. So there are 1,000 milliliters in a liter.
What type of frame rate you get on this bad boy?
I can choose between 29 or 30. Or if I reduce the resolution, I can make it 60. I picked the higher resolution because I wanted people to be able to see the board. I think it's 1920 by...
Does 29.166 sound right?
I don't know, you have to say it again. 20 what?
29.166.
Wait, yours is on.
29.2. We have 3 sig figs. 3 sig figs. Everything else here is exact. So 29.2, we have the same number of sig figs as our... Oh, and BT dub, is this 0 significant? Yeah, because it's between 2 significant figures. So 29.2 liters of potting soil. Questions? You'll have 2 worksheets and a chapter review to do on this. Do you need me to elucidate any of the steps? Well, how am I going to stop this recording?